So now Keith is going to present the status report for Glamor, the OpenGL-based 2D acceleration.
Okay, I realize that I am positioned between you and your lunch. So I will try not to run over. Of course, I have about twice as much material as I need for a half an hour, so I will probably be skipping some of the slides, just to let you know. Just a quick overview, what is Glamor? Glamor is an X rendering backend, like Exa or Uxa or SNA or any of those XAA, any of those fine rendering backends. But it's based entirely on GL or GLES. It uses either EGL or GLX. It's totally hardware independent. If you have GLES or GL, you can run Glamor. It's pretty zippy these days. Oddly, this is drawn with Glamor, so the whole talk is a live demo. Where did Glamor come from? Eric started it back in December of 2008. The goal, of course, was to offer this notion of a hardware-independent X acceleration. We all spend a huge amount of our lives, well, many of us have spent far too much of our lives writing X acceleration code. I know that I've written probably 4 entire copies of the X rendering infrastructure using software. This is the first time we've done one in GL. The problem was back in 2008, I don't know how many of you remember how bad GL was back then. It was kind of barely alive in Linux. We had barely gotten to the point of some hardware having GL2 support. Most of our stuff was still back on GL1 stuff. As a result, actually trying to do Glamor back then was, was optimistic at best. Then later, a couple of years later, a couple of Intel folks in China, Zhigang and Yunyan He, took over a bunch of Glamor development for writing acceleration for some Intel hardware that we like not to talk about. The GMA 500 series and other stuff using non-Intel GPUs with closed source GL drivers and no accelerated 2D at all. So their goal was to use Glamor to get some acceleration for X2D operations on hardware that we couldn't write direct 2D acceleration for it. All we had was these closed source GL drivers. The problem with that was that the SGX hardware at the time was pretty bad and the GL drivers were really unstable, and it didn't work out very well. At the point of 2011 was that GL was a lot better, and so they added a lot more GL2 code, and they started trying to take advantage of what modern GL implementations on our hardware can do. Mid last year, Glamor was mostly complete. It basically did everything you needed to do for X. Obviously, it's missing some stuff that GL just doesn't do, like plane masks. GL can't do arbitrary X plane masks. So if you want to accelerate your 8-bit double buffered stuff, yeah, not so much. One of the things that when you looked at the Glamor code from mid last year, what you noticed was that it looked a lot like the FB code. The FB code had some very low level, very small primitives to draw a rectangle or draw a line or draw a bit of text. Which works fine when your overhead for each call is basically 0. But Glamor was structured in much the same way, and the problem with that, of course, is the GL overhead for each primitive is not 0. And the result was that Glamor was horrifically inefficient for drawing lots of operations. And so it was much slower than software for many things, which was kind of painful given that it was supposed to be a lot faster. And the other thing is when you profiled it, you noticed that Glamor was consuming huge amounts of CPU at the time. To draw dots, because it was doing all the clipping and all of the coordinate transformation with the CPU. So when we started looking at Glamor and kind of revisiting this, it's like, well, what can we do today? And what are people doing with it today? Well, one of the big things that changed was that the Radeon driver developers said, we could just use Glamor on our hardware and we could give up on this notion of having custom X2D code. Wouldn't that be nice? It would reduce our workload. A bunch of other people were thinking about the same thing, and certainly I was thinking about that in the face of the growth of the acceleration code in the Intel driver. Eric kind of readopted Glamor last fall, and just after LCA last year, I started hacking on it a bit as well in March of this year. And so at this point, we've got this acceleration infrastructure that's got some fundamental architectural and performance problems that have developed out of the history of its history. What do we do with that? So one of the things that has been fixed and works quite well in Glamor is some of the fundamental Pixmap support and some of the notions of how to support Pixmaps in Glamor. One of the big problems with GL is that textures are generally smaller than the X Pixmap limits. In X, you can create a Pixmap up to 32K pixels squared, which is a healthy size texture. And certainly Intel hardware doesn't go that big. Maybe NVIDIA hardware lets you allocate 4 gigabyte textures. I don't know. It's a pretty healthy chunk of memory. So obviously what we need to do is we have two choices. We could either say if you make a Pixmap larger than the tile size, we fall back to software for everything, or we can do some clever hacks. And the clever hack turned out to be allocating, kind of tiling all of your textures into a Pixmap. The drawing to a tiled output is really easy. You just iterate your drawing over all the output and it just works. The source, though, was always a puzzle, but Zhizhong actually figured out a really cute hack where you tile the output rendering such that each tile is smaller than the source tiles, and then you construct intermediate tiles that cover the gaps between them and copy the bits from the source in to kind of paper over the gaps. And so you get so if you're doing upscaling or downscaling or other transformation of your source data, you end up with these temporary tiles that cover the gaps between the two tiles in the source, and so you get continuous sampling across that, which is what you want. And that turned out to be the key insight, was that we could actually do fully tiled input and output by this horrible hack. It's horrifically slow performance-wise, but to first order we don't really care because most applications aren't ever going to do this. And when you do this, it's still way faster than falling back to software. So here we have a way of taking care of the large X images and still getting acceleration. And it turns out we use this all the time. If you have a large image and you load it up in Firefox, Firefox actually constructs a Pixmap the size of the input image, however large it is, and then uses the render extension to scale it onto the screen. I had an image that was 32K pixels tall. It's one of those huge comics that you get where it's single panels, and when Firefox first opens it up, it's about 10 pixels wide and the entire screen tall. And the first time I surfed over to a page there and it seg-faulted, it was like, oh, I'm using my cool Glamor code. Awesome, I have a test case. Yeah, it's always nice to get test cases. So I went ahead and fixed that recently, and that was kind of nice. Okay, one of the other things that kind of don't match between X and GL are pixel formats. X pixels have no intrinsic color information. This is really hard for a lot of people to grasp. When you stuff pixel values into a Pixmap, there's no color associated with them at all. They don't have a red, a green, or a blue, or an alpha. It's just a bag of bits. Windows, when you draw them on the screen, those have a visual, and that tells you how to interpret the bits in your image for which bits are red, green, and blue. Bits beyond the red, green, and blue bits, those have no core protocol meaning. But in general, we interpret those as alpha bits. Yes, just like the old serial. Render pictures are how we take the pixels from a Pixmap and get red, green, and blue data into them. The awesome part, of course, is that you can have multiple render pictures pointing at the same underlying Pixmap, which means from that Pixmap you can actually have multiple interpretations of the pixel data in terms of red, green, and blue. You would think this would be insane and nobody would do that, except that GTK does. It uses ARGB and I don't know, a couple of other crazy formats to reinterpret the bits within a Pixmap in two or three different formats. Oh, in the same operation. Oh, yeah, of course. Of course, you wouldn't want to at the same time. Okay, so what does GL do with pixel formats? Well, in GL world, there are 4 channels. Their names are RGB and A. Please don't infer any semantic meaning, underlying meaning deeper than the names RGB and A, because there isn't any in GL. They really are just those 4 names. Textures have an intrinsic channel information, which is to say a texture knows which of these channels it has. And you could have A textures or RG textures or RGB textures or RGBA. You can't have any combination, but you can have lots of random combinations. Surfaces have channel information. Right, textures tell you which channels they contain. Data, when you hand data from the application to GL, you have to tell it how that data is laid out. But GL doesn't let you know what the actual format of the data is in your texture. So if it's going to take your 8888 data and convert it down to 565 data and throw stuff away, well, yeah, it sucks to be you. But you know, the GL is clearly allowed to do that. There's a new extension, however, that lets you take a texture and rename the color, the label. So you can say, yeah, I've got this RGB texture here. I want you to pretend like the A texture is now named R, or the R texture is now named, you know, A, whatever. So you can remap stuff. That's really awesome because it solves one of the fundamental problems we have that GTK is doing, where it's effectively using 2 pict formats for the same picture, which is to say it wants 2 different mapping of the underlying channel data. It doesn't solve all of my problems because one of the common pict formats that I have these days is 10.10.10.2. And so here I upload 8888 data into a Pixmap, and then I say, oh, I was lying. That's actually 10.10.10.2 data. So what do I have to do for that? Well, oftentimes I have to reformat the data with the CPU. So I actually have to take my Pixmap, suck the data back down into the CPU, change the labels that I'm going to use to call what data it is, and put it back into the texture, or create a new texture. Glamor does not do this correctly today. So that's one of the big limitations of Glamor right now, is we have a horrible mess with certain applications doing render stuff. Okay, so now we have the ability to store pixel data in arbitrary X pixel data in textures. What happens when GL can't draw what I need to do? Well, I need to use a fallback, and for the fallbacks, what I do is I create a giant PBO, which is a pixel buffer object, and those can be as big as you want, up to the size of an X Pixmap. And I take all of my tiled textures and I blurk them down into this giant PBO, and I hand the PBO off to my software rendering code, and it draws whatever it wants to do. And then I take the result of that rendering and I pump it back up into the textures. It's shockingly efficient on Intel hardware, at least. I haven't tested anything else, because the PBOs are all managed by Mesa, and it actually does a fairly efficient data transfer between the GPU and the CPU, as efficient as it can. And the other thing is that I do for fallbacks is if the operation knows kind of a bounding box of it, so if you're doing a blit or something and it knows an obvious bounding box of the operation, then I can limit the download data to the size of that operation. So if you're writing to the screen, if you're uncomposited and you're drawing to the entire screen, but you're only scrolling a tiny little window, then it only downloads the data from that window, even though the PBO that it allocates is the size of the screen, so that I don't have to figure out some weird stride and offset disaster. But I do at least limit the download and upload part. So Glamor for Core X, this is what I spent time this spring doing, I rewrote all the core rendering code. And Eric was kind of appalled. It's like, well, can't you incrementally change the current rendering code to work better? And yeah, I like to write stuff. And it had been a long time since I've gotten to write a new code, so that was fun. The goal, of course, was to eliminate all the CPU time that we spend in Glamor. I did a profile. It was horrifically expensive, and it's like, okay, how can we do this better? Well, how about if instead of having the CPU do computation, we take this giant parallel processing engine that I have attached to my computer and let it do all this computation instead? And so one of the things I wanted to be able to do was to have a lot of different shaders that could actually deal with all this stuff. The problem is that when you have different primitives and different rendering formats and different rendering operations, you get a kind of a combinatorial explosion of permutations of operations. And so what I wanted to do was construct an appropriate piece of GLSL that did every operation optimized. And so I had this dynamic shader generation architecture that glues these little chunks of GLSL to code together and compiles it at runtime. So the nice thing here is that I optimize everything, but I only compile the GLSL programs that I actually use because I compile them at runtime. It's like you come in with some nut job operation, and the Glamor says, oh, yeah, I know how to optimize that, but I haven't bothered yet. And so you go off and compile just that operation. That way you don't spend a huge amount of time at startup, and you spend time incrementally as you do crazier and crazier stuff. I wanted to show you a little sample of how this works. Here's a little definition of how you draw rectangles if you have GLSL 1.30. There's a similar one that's a little different for GLSL 1.20. It's slightly, it doesn't use instancing. So you declare what your little chunk is here, and the position is going to compute the coordinate of the 4 sides of the rectangle from the input X data, and it does this magic instancing trick to actually extract the position. Here's all the setup code to allocate the vertex buffers. Eric says I can make this a bunch faster with VAOs, and I probably will try that. And then this is the whole drawing loop. It literally is just mem copy the data in and draw it. And that's so you saw what it costs to do polyfill rectangle. Why we need to optimize Glamor for render. The current code looks a lot like the old core code. It does a lot of stuff with the CPU. We need to fix that. Obviously, the future plans are to make this totally awesome. So next year at XDC, I'll show you how awesome Glamor is here. Right now, what do we require for Glamor? We require GLSL 1.20, but if you have 1.30, it's a lot better. Obviously, GL Desktop 2.1 or better, GLES 2.0 or better. Also on GLES, we require the BGRA 8888 texture format. Otherwise, we suffer, and it doesn't run at all. If you have these extensions, things go better. What are our projects? Upcoming projects, if anybody wants to help out, here's a lot of stuff we can do. We need to rework the pixel format code. That was that bug I told you about earlier. To deal with multiple picked formats and take advantage of the texture swizzle extension. There's an optimization. I told you the Pixmaps are tiled into textures. Well, there's an optimization that does the single tile case. It's just a pessimization because you always have to check. Do I only have one tile here? Yes, go through the one tile case. Otherwise, go through the multi-tile case. So that's not an optimization at all. I want to rewrite all the render text and the rest of the render stuff. Here's the kind of the short synopsis of what I'm going to do text in render. Obviously, I would love to go play with rewriting the fragment shader-based trapezoid code. There was an early implementation of that wasn't compliant with the spec, and so we threw it away. We want to use vertex attribute objects, and we want to finish the rest of the work to transition Glamor to supporting core contexts. And with that, do you have any questions or comments? Because Martin said I had to be quick.
Oh, yeah, well, you had 5 more minutes.
I know, so we have time for questions.
Great.
So has anybody else tried this on non-Intel hardware? Any experiences? How is it working on Radeon these days? Anybody know? Great. Is it awesome? You guys going to help out at all?
Hopefully.
I got lots of projects for you now.
Nouveau started using it for Maxwell, the new generations. But yeah, not many users actually tried it.
Okay.
Yeah,
So Nouveau has 2D acceleration code for older hardware?
Yeah. EXA.
Okay, you might try Glamor and see how it is.
Well, Ben implemented it. I don't know how it works.
It works well on Maxwell. I haven't tried it earlier.
So, okay. Works on Maxwell.
Well, go try it on earlier hardware. I bet it's better than Exa. Okay, so Nouveau's not good enough for it yet.
You tried it? Oh, okay.
I think ext GPU shader 4 gives you actual integer channels, including all the bitwise ops you could want, so you can do plane masks.
awesome.
Congratulations. I'm sure you wanted that.
Eric says no.
So the problem with plain masks is that you need to be able to look at the contents of the destination to be able to do your integer ops on it. Now, for those of us that are working on tiled renderers, a lot of us actually could read our destination. So we need to cook up a little extension for that.
There's an Apple extension for that for GLES already. It's you're allowed to read out the frame, but the fragment, the destination.
Well, there's an
Yeah,
NVIDIA
I want
extension that
that.
lets you do that as well.
Yeah.
Yeah, the NVIDIA extension's a little more irritating to use because you have to actually bind the destination as a texture.
Yep.
So there's a bunch of extra setup overhead when really I actually just want to read my destination pixel and the hardware really wants to let me do that.
Yeah.
Yeah. The other option for the plane mask case is if you are doing a plane map, you could just copy it aside, and it would probably still be faster than software.
Yeah, you have to break down each primitive then. Break down your operation into per primitive.
It would be tedious.
No, you don't.
Yeah, tedious but doable.
No, you don't. You. Oh, yeah, you do, because polyfill rect can have overlapping rectangles.
Yep.
I apologize.
We can discuss how to do this over beer.
That's a good idea.
So I'm planning to keep working on this. Anybody else wants to pile on? I would love to see most people using Glamor. If they are able, if their GLs can support it. I think almost everybody on Radeon and Nouveau should be able to use it. It would be awesome if we could throw away all of the other rendering code pretty soon. Who else wants to get rid of that pile of steaming 2D garbage? Yeah, pick me, pick me. Thanks, guys. You ready for lunch?
Yeah. So, oh yeah, thank you very much.
Thank you.